How am I going to be able to cover all you need to know about factorising in about 10 minutes? Well, that's my challenge. Let's see where we go. Welcome to this, our video for today on quadratics, leading towards some very exciting knowledge. In our last video, we looked at the idea of moving quadratics around and solving them by completing the square, and we talked about intercepts. Now today, we're moving on towards looking at this intercept idea in more detail. What is an intercept? For those of you who've just watched this video, well, an intercept is where it crosses either the x-axis or the y-axis. Well, we have tools to allow us to help us find our y-axis intercept, because if we have the equation y equals x squared plus 3x minus 6, we've pretty much decided that because this line here, which is the y-axis, has the same equation as x equals 0, then by putting x equals 0 into this equation, we find that this number here, which gets left on its own, is our y-axis intercept. Now, that's nice and easy. It's found when we have our quadratic in intercept form. Again, remember, this thing here is intercept form. Not all of the times do we get our equations in intercept form, or in fact we need them in intercept form, because trying to find these x-axis intercepts is quite complicated. Really complicated? Not after this video, it won't be. Let's go back and have a look at what we might need to know to help us get to this. Now, at the end of this video, we'll give you an idea, but we're just going to go back to some of the tips and tricks about factorising and where questions try and trick you. Because remember, maths is a big fat trick. Let's look at example 1. Here, we have some basic questions. There are 4 different questions down the bottom, and some useful information at the top. And what does it say? It says, always take outside of a set of brackets every letter and number which is common to each term. This is basic factorisation. And this is where people start making horrible mistakes later on with quadratic factorisation because they don't see the tricks. They get so used to seeing this x squared, they start making horrible mistakes. But nice and easy does it. Start first. We've got x squared plus 2x. Now, following the rules, it says we've got to move outside of a set of brackets every letter and number which is common to each term. If you remember, this here is a term and this here is a term. So let's see what's common. Well, does this have any numbers in front of it? Nope. This does. It's not important to me. Does this have any letters? Yep, it's got an x times an x. This has got 1x inside. So there we go. They share an x. So what I'm going to do is move outside of a set of brackets that x. Now this is where it gets quite funky because there are lots of ways of remembering now what you're doing. Ideally, what you're trying to say is if I move an x outside of some brackets, what do I multiply x by, what goes in this first term here, to give me x squared? Well, hopefully x times x gives me x squared. And again, what do I have to put in this part of the bracket to get plus 2x? Well, hopefully I would multiply it by plus 2. And ladies and gentlemen, there we go. We have our first expression factorised, just by moving outside everything inside that's common. Next example, yep, 3x squared plus 6x equals. Same idea, I'm going to draw a set of brackets, because I like brackets. And let's have a look. Right, this has a number, and this has a number. Now, what can 3 and 6 be divided by? What is the biggest thing we can take out of them, or in fact factorise? What is the biggest factor of 3 and 6? Well, hopefully all of you think it's 3. I'm going to leave a little gap there, which probably gives you an idea where we're going next. So we've dealt with the numbers, let's look at the letters. What have we got here? We've got 2 x's, or x times x. And what I've got here, I've got 1x, so again, I can move an x outside. Well, what do I need to multiply 3x by to get 3x squared? Got to be x. And what do I have to multiply 3x by to get plus 6x? Once again, plus 2. Now again, this is just fluky. The fact I've got plus 2 in brackets is irrelevant. Ooh, ramping up the complexity. 3a x squared plus 6a squared x equals. Ooh, very exciting. Right, let's look at our numbers first. 3 and 6 again. We already know that that can have a factor of 3 because the biggest number that goes into 3 and 6 is 3. I've got here an a, an x and an x together. And here I've got an A, and an X. So what is common to both of them? Well, I've got an A in both of them and an X in both of them. So that's what I'm going to move outside. the a and the x. You have to move out the maximum. You have to move out as much outside the brackets as you possibly can. So there we go. Once again, what do I multiply 3ax by to give 3ax squared? Well, I'm going to do an x in here. And what do I multiply 3ax by to get 6a squared x? Well, 3, I have to multiply it by plus 2 to get the 6. And I've got 1a outside, I need 2. So there's my a. Oh, something slightly different. And last example. 5x squared plus 10x plus 25 equals, I've got 3 terms now. Does that change anything? Nope. What do I have common? Well, I've got a number, I've got a number, and I've got a number. So it's 5, 10, and 25. Well, the biggest number that will go into 5, 10, and 25 is 5. I've got a letter, ooh, no letter, which means because I don't have a letter in every single term, that's all I can take outside is the 5. So what do I multiply 5 by to get 5x squared? X squared. What do I multiply the 5 by to get 10x? I get times it by plus 2x. And what do I go in here? Plus 5, because 5 5s are 25. Big hint here, and it's really quite massive, is to notice that every single one of these questions, barring this last one here, and I threw that in as a bit of a curveball, every single one of these first 3 parts has only 2 terms in it. That's critically important to quadratic factorization a bit later on. If it only has 2 terms, wow, life is really easy. So that was basic factorization, where you remove what they call the highest factor. So now we can move on to factorizing in pairs. Well, we know what a pair is. A pair is 2. And this is particularly useful when we have 4 terms. Let's look and see what I've got. And I'm just going to give you an example of how to make this work. I've got x squared plus 3x plus 6 plus 2x. Now, I know most people will sit this moment and go, I can add the 3x and the 2x together, and that actually isn't going to help us factorize. We have 4 terms. We like 4 terms because it can be divided by 2. And so what I now do, or what I can now look at, is the idea of factorizing in pairs. So what I do is I look at those 2 and those 2. Look at the first pair. Well, there isn't a number in each of them, so it must just be a letter. I've got x times x there and just 1x there, so I can move an x outside. What does that leave me with? Well, it leaves me an x plus 3 inside my brackets. Ooh. What do I get here? Well, I've got a number and another letter term. I've got 2 terms. Hold on, they can both be divided by 2. So I can move a plus 2 outside my brackets. And what do I get? I get plus 3. And I get plus x. Now I'm actually going to write this around in a slightly different way, because hopefully you are aware that x plus 3 and 3 plus x are the same. So I'm going to write that around a different way, and I've deliberately made this slightly complicated. What do I now notice? Hold on a moment. How many terms have I now got? In fact, you might look at that and go, well, there's like 17 terms. There aren't. There's only 2. A term is where something gets separated by a plus or a minus on the whole. And this is all connected together by times. The bracket says treat this as one thing. So I've got something times something else. That's actually a term. I've got something times something else. That's a term. So I have 2 terms here. And what does factorization tell us? Move outside anything that is repeated in each term. Well, I now see that this x plus 3 is repeated twice. So I can actually move that outside of a set of brackets and work out, well, okay, what do I have to multiply x plus 3 by to get x times x plus 3? Well, hopefully you'll see x. And what do I need to multiply x plus 3 by to get plus 2 x plus 3? Well, plus 2. And there we go, ladies and gentlemen. That actual top equation here, or top expression, can be written as x plus 3 multiplied by x plus 2. Wow! That looks pretty funky. So once again, just remember that having 4 terms is really quite useful to us. 3, not so useful. 2, pretty useful. Let's have a clean sheet to now have a go at the second question. What have we got? We've got x cubed plus 4x squared minus 3x minus 12. Let's look at them in terms of pairs. We've got a pair there, and we now have a pair there. Right, well, what do we actually have common to each of our first pairs? Well, we've got an x, an x, and an x there, and 4 and an x and an x. So that means I can move x squared outside my brackets. What does it leave me with? Well, x squared times what gives me x cubed? X, and x squared times what gives me 4x squared plus 4. Now let's look at this thing. What have I got? I've got minus 3x and minus 12. What can I take outside that's common? Well, there's no letters common, so it must be a number. And the biggest factor is actually minus 3, which leaves me x plus 4. Because if you remember, minus 3 times plus 4 is minus 12. Hold on a minute, Chuckles. What do I notice? I've got two terms, and on each of those terms, I've got a bracket that's the same. Yep, I don't know what the accent is about either. So, means I can factorize again. If they each have something that's the same in each term, I can move that outside a set of brackets and write down what I have left. Effectively, I have, if this x squared term is multiplied by this bracket, then actually that must go inside this second set of brackets. And again, I've got this minus 3 times this bracket, and that goes inside, and lo and behold, we have factorized. This sort of process is going to come in handy a bit later on, in fact in a later video. So just try and remember that. Our next section deals with the difference of two squares. In the bottom board we've had an example here of x squared minus a squared equals a. Let's just prove that. What we're trying to say is if we have an x squared, or a square term, minus another square term, and big hint here, it only works when it's minus, as it says at the top here. The difference of two squares only works if there is a minus or a negative sign between each of the square terms. It doesn't work otherwise. So we have x squared minus a squared, and it is suggesting that that can be rewritten as x plus a, x minus a. Let's just see if we can prove that by doing it the other way around, using FOIL. So x times x is x squared, and x times minus a is minus ax. Plus a times x is plus ax, and plus a times minus a is minus a squared. And hopefully you'll see that a minus ax and the plus ax disappear, and what does that leave us with? Yep, x squared minus a squared. Oh, okay, so that's a theory. So what we're saying is we can write two squares when they're minus in a factorized form. Yep, pretty sure we can. Let's try an example. What happens if I have 16x squared minus 25? Well, maybe one of the easiest things to realize is to write that out as being, well, 16 is a square number. We know that because the square numbers, if you remember, are 1, 4, 9, 16, 25, 36, 49, and so they go on. All right, so a number times by itself. Well, 4 times 4 is 16, and 5 times 5 is 25. We can actually write this out as 4x all squared minus 5 squared. And if you now compare that with x squared minus a squared, what we now have is our value of x is 4x. I know that sounds a bit silly really. And a is equal to 5. If we know that x squared minus a squared can be written out as x plus a and x minus a, then what we're saying is we can write that out as 4x plus 5 and 4x minus 5. Ooh. Again, you may be sitting there wondering why it is we seemingly want to get things in this bracket times a bracket business. Well, that's coming up in a slightly later video, but let me just say it's really important for intercepts of quadratics to have our factorized form in a bracket times a bracket. What if we have 3x squared minus 75? Well, hold on a moment. 75 isn't a square number and 3 isn't a square number. They're trying to trick us. They're trying to use two bits of factorization in one. We've got this minus sign in front, which sort of gives us a hint, and we've got two terms. Remember, when there's two terms, there's almost always a trick. What I do know is that 75 and 3 have factors of 3. So I'm going to move a 3 outside my brackets, and what do I get? I get x squared minus 25. Aha! Hold on a moment. 25 is a square number. We like that, and it's got a minus sign in front of it. So if we were to break this out and do this as its own calculation and have x squared minus 25, we know that's the same as x squared minus 5 squared. And using this general idea over here, we now know that that can be written as x minus 5, x plus 5. And again, that is just the same as x plus 5 times x minus 5. Right, so having broken it out, we can now break back in, and we've got our 3, and we can replace that with x plus 5 and x minus 5. Now sometimes they will multiply the 3 out inside one of the brackets, and please remember that 3 only belongs to one of the brackets. Doesn't matter which one you want to have, but it only belongs to one. So that would be exactly the same as 3x plus 15 multiplied by x minus 5. All right? Or there's another way of doing it as well. One more example? I think so. Let's throw some complexity into this. What about x minus 4 squared minus 16? We can see through this now. This isn't difficult. Nope, because we now know that that is the same as x minus 4 squared minus 4 squared. So there are our two square terms. I can just now substitute into brackets. It's going to look a bit weird because if you remember now, this x that we're going to substitute in is now going to be x minus 4 and the a is going to be 4. So let's see what we get. We get x minus 4 plus 4 multiplied by x minus 4 minus 4, right? Remember, this is my plus a, and this is my minus a, and this is just the x term. And because we can, this is going to lead a little bit of simplification. So x minus 4 plus 4 is just equal to x. And x minus 4 is x minus 8. Now these brackets around this x are actually pretty irrelevant. We don't really need them. Sometimes they'll put it in to throw you. More importantly later on though, that actually means something. There we go. So even with letters or more than one term, it's not difficult. Just remember it's got to be a minus sign. This method is pretty crucial, and I'm going to show you the basics now. We'll start with a bit of theory, and we'll go, well, if I have something that once it's been factorized looks like x plus a, x plus b, what would that look like if I FOILed it? Well, we know what FOIL means. We do first times first, first times second, second times first, and second times second. So x times x is x squared. X times plus b is plus bx, plus a times x is plus ax, and a times b is plus ab. Oh, this is a bit funky. I can factorize this because I've got a pair of terms that can actually be factorized. I can't add them together because I can't add apples and bananas together, but I can factorize. And so I get the x squared plus a plus b in brackets times x plus ab. Well, I suppose you're probably asking, what's that got to do with the price of fish? Well, let's just see what actually happens. That looks very similar to a quadratic equation. And in fact, it is. Remember, our quadratic, an example of quadratic could be x squared plus 4x minus 12. And if we compare, because maths is a lot about comparing, what do we notice? We notice that in front of the x is this plus ab, and in front of the x here is plus 4. And in front, and at the end, the constant is given by plus a times b, and at the end we got minus 12. And so just using a little bit of comparison, what we can now say is, well, all right, that seems fairly sensible. We know that a plus b must be equal to 4, and that a times b must be equal to negative 12. Now, we could go into pages of actually how to do that, but there is a shortcut. What I'm going to do is I'm going to draw a T. I'm going to show you why now. I'm going to write the fact that I've got two numbers multiply to give minus 12. I don't know what those two numbers are, but the chances are they're going to be factors. So what are the factors of minus 12? Well, there's minus 1 and 12, minus 2 and 6, minus 3 and 4, minus 4 and 3, minus 6 and 2, and minus 12 and 1. So those are all the numbers that when multiplied together give me minus 12. Are there any two numbers which add together to give 4? Yeah, actually, as it turns out, there we go. I know that A and B, when added together, give me minus 2, and 6 gives me 4. So I now know the value of A is minus 2, and B is 6. You're probably going to say, well, does it matter which way around you get them? Not at all. So using this rather funky T idea, what we find out then is that, yep, let's just see, what do we have? What do we have? We end up with x minus 2 and x plus 6 is my factorized form of x squared plus 4x minus 12. Ooh. One more example. I should go. Let's try and make it a little bit more complicated. Okay, so let's have x squared plus 11x plus 10. Right, that's our quadratic. What do we know? Well, if we remember from our previous screen, we know that x squared plus a plus b times x plus ab is the generalized form to help me find out these values of a and b. Now, there's a big trick here. Notice that the number in front of here is a 1 and the number in front of here is a 1. This method only works with this formula when this is a 1. But actually, just bear with me. Right, so what does that mean? Well, comparing again, we know that a plus b is the number in front of the x. So a plus b must be equal to 11. And a times b must be equal to plus 10. That can't possibly be possible. Can't possibly be possible? How many possibles can I get possibly into one sentence, possibly? Well, let's draw our T method. And what value goes on the top? Remember, it's the number here, the a times b. So let's write positive 10, and that's really important that we write that positive. So what are the numbers that are factors of 10? 1 and 10, 2 and 5, 5 and 2, 10 and 1. Good. So we now know the numbers that multiply to give 10. Are there any numbers that add to give 11? Actually, yeah. What we've done is we found two sets. So that tells us that A can be either 10 and B equals 1, or the other way around. Again, it really doesn't matter. Using the information that we've got above then, we know that x squared plus 11x plus 10 becomes equal to x plus 10, x plus 1. And people said this factorization was complicated. Just highlighting for the last time, why are we factorizing? We are factorizing to help us find the x-axis intercepts for our quadratic, assuming that there are going to be some. Remember from our last video, we can test to see whether it's going to cross once, twice, or not at all. Well, I'm going to tell you now that this has 2 crossing points. The next video will explain why. Hopefully you've understood. Have a good day.